Hi, I'm Mr. True. We're going to continue our discussion and work with algebraic fractions. This issue came up once or twice in my other videos dealing with fractions, so I want to do one with just this concept if you're struggling with it. That's complex fractions. That's when the numerator, the denominator, or both has one or more fractions in them, or a power which is negative. And to get rid of that negative exponent on the base, you'll have to move it and maybe move from the numerator denominator or create a fraction where it appeared there wasn't one before. So what we're going to have to do with these problems is simplify the numerator and denominator separately until we get one fraction in the numerator and one fraction in the denominator. And then, remembering that a fraction bar is nothing but division, we're going to multiply the numerator by the reciprocal of the denominator. We're going to take that bottom fraction and flip it up and change it to multiplication, and then simplify whatever's left. Now, if you've been watching a lot of my videos, you know I don't tend to do very short ones. Why is that? Because I give you lots of examples. So we have, I think, 5 or 6 examples coming up in this video and increasing in difficulty as we go. So let's get that started. Woo! The first 2 examples are numerical, just to make sure that you're comfortable with fractions, and if not, dust off the skills you need for those, and give you some examples you can type into your calculator and see, oh, okay, this really does work. We've got 1/2 over 4/5. That is the same as 1/2 divided by 4/5, and that is equal to 1/2 times 5 over 4. Now, I'm showing you with this main fraction bar that, as my notes reminded you, is a division symbol. So I'm not going to write it like this every single time. All I'm going to do is say that when you have a fraction over a fraction, remembering that that fraction bar means division, you are going to multiply by the reciprocal of the fraction that's in the denominator. So that's going to be 1/2 times 5 over 4, and that is equal to 1 times 5, which is 5, over 2 times 4, which is 8. Let's see, I was going to say something here. Oh yeah, let's not forget you do not need common denominators when you multiply in fractions. Just go straight across the top and the bottom. This is again numerical, but it's a little bit more complicated. We do not want to take that bottom fraction and flip it up until we have a single fraction in the numerator and in the denominator. It's really most important that the denominator is only a single fraction. You don't want to skip that step of finding a common denominator, and you will do that if I were to take these bottom 2 fractions right now and flip them up. But I do like to, that's why we want one fraction in the denominator. I do not like to really flip that bottom fraction up though until, again, there's a single fraction on top and a single fraction on the denominator. So we're going to find a common denominator here by multiplying top and bottom by 3 to get that 3 times 2, which is 6. This 2 is, or can be rewritten as 2 over 1, so that's going to get multiplied by the numerator and denominator by, again, 3, so we can get that common denominator of 3. When we do that, I get 2 times 3, which is equal to 6, minus 1 over common denominator of 3. I do that's 5, but I'm just teaching here. And 3 times 3 is 9, so 9 minus 1 over that common denominator of 6. Now, I'm going to go ahead and do that subtraction that's in the numerator of each of the fractions here, and also at the same time flip that bottom fraction up. So we have 6 minus 1, which is 5, over 3, times, here's that multiplied by the reciprocal of the denominator, or that second fraction, times that 6 is in the denominator here, it's now going to be in the numerator, over 9 minus 1, which is equal to 8. Now, you can either multiply these fractions first, or you can cancel out first. It's your choice. Since this is all numerical, and the numbers are small anyway, let's go ahead and just multiply straight across. 5 times 6 is equal to 30. 3 times 8 is equal to 24. And these 2 numbers both have a common denominator of, looks like 6. So we're going to divide the top by 6. The bottom by 6. 30 divided by 6 is equal to 5. And 24 divided by 6 is equal to 4. And that's the end of our second example. The next 2 are going to be algebraic in nature, and then the next 2 after that, same, all algebra, but getting a little bit harder as we go. Next example. we have 2x plus 2y over x to the negative 1 plus y to the negative 1. It kind of appears like we don't have to do anything with this problem. It sort of looks like it's already in simplified form, but we have those negative exponents, which we do not want in our final answer. So we're going to get rid of that negative power of 1 by moving the x into its own denominator. Same with the y, and when we do that, we get this. 2x plus 2y over 1 over x plus 1 over y. Both of those now to the power of 1, not negative 1 because we moved their bases into the denominator. Now we see that this is a complex fraction. Also, I'm going to make sure we highlight the main fraction bar in case there is any unclearness about that. We're going to find a common denominator, so we're going to have to, probably just put colored chalk on my face. We're going to have to multiply this by this fraction by x, top and bottom, numerator and denominator. This one by y. So we have those two bottom fractions, or those two fractions in the denominator having their own common denominator. That is going to come out to be 2x plus 2y over y plus x. And addition is commutative, so y plus x is the same as x plus y, over our common denominator of xy. Now, again, the main fraction bar was underneath 2x plus 2y, so it's right there. And we're going to flip that bottom fraction up. So we're going to take that bottom fraction, again it's 2x plus 2y divided by this fraction in the denominator. We're going to change that division to multiplication. So we're going to flip that bottom fraction up and get 2x plus 2y over 1. I'm going to highlight that numerator notation, or that fraction notation for the numerator, times, now we're going to take the bottom and flip it up, we get x, y over x plus y. I'm going to go ahead and change the order of that addition. And again, this was the fraction in the denominator and it's getting flipped up, or we're multiplying by the reciprocal, the numerator by the reciprocal. Now to save some space here, I'm going to go ahead and at this point, see I'm doing my scratch work in blue, I'm going to take this numerator and factor it. These two terms both have a common factor of 2. So we're going to write 2 times x plus y. Now when I do that, I can see that this denominator, remember this fraction bar acts as a grouping symbol, so down here in the denominator we have x plus y, and we have that factor in the numerator of my first fraction. So those x plus y's as common factors across the multiplication symbol are going to cancel out. And so this just becomes 1, so 1 times 1 is 1, and the numerator is 2 times xy, and that is the end of our problem. And as we get into these algebraic fractions, please remember again, we're just allowing, for convenience sake, we're allowing all the variables to have a domain such that they can never have a situation where you're dividing by 0. So I'm just showing the algebraic manipulation to simplify these fractions. Let's just assume the domain of our variables are all such that we do not end up attempting to divide by 0. Here we have, again, ever increasingly complexion, so we have a little bit harder problem here. We have 2 fractions in the numerator and 3 fractions in the denominator. We need those common denominators, because again I want 1 fraction on top, 1 on the bottom, and then we're going to multiply by that reciprocal. So we have x squared and y squared, so we're going to multiply this by x squared in the numerator and denominator. We're going to multiply the first one by y squared, try to get that common denominator. And then down here in the bottom here we have an x squared in this first term. The middle term only has an x in the denominator, and the second term doesn't have any. So we're going to multiply, I should have left more space here. We're going to multiply this by x in the numerator and denominator, and this third fraction doesn't have any x value, so it's going to get, or any variables of x's in it in the denominator, so we're going to multiply it by x squared in the numerator and denominator. This has a y squared, this only has one of them, so we're going to also multiply by y in the numerator and denominator. I hope this isn't too small for you to see. We're crowded. The first denominator only has x squared, so we're going to multiply it by y squared. When we do that, let me clean this up a little bit. we have y squared times 1 and x squared times 1, so we have y squared minus x squared over our common denominator of x squared y squared, or y squared x squared, whatever. Our main fraction bar here, and in the denominator we have 4y squared minus xy minus 3x squared all over our common denominator again of x squared y squared. Now we only have one fraction in the numerator and denominator. So we can take this denominator, let me pick a different color here, and sort of just, I'm going to just cross this out to save a little bit of space and flip that up and show that we are multiplying by the reciprocal of the denominator. So we're going to multiply by x squared, we're flipping that denominator up, multiplying by its reciprocal, over 4x or y squared minus xy minus 3x squared. Okay, well when we do that we can see that the x squared, y squared factors are going to cancel out. Some more is going to cancel out as well, but I want to clean this up a little bit. So when we do that, we get y squared minus x squared over 4y squared minus xy minus 3x squared. Our numerator has a difference of squares, so that's going to be able to factor and give us, this here is going to give us y plus x times y minus x. Our denominator, well, our denominator does not have is a trinomial. It's got powers of 2 in here, and it does not have a leading coefficient equal to 1. So we're going to take the first and last, I would have called this a constant with other problems, but this is a bit more advanced with the variable in the last term. So, but we're going to still take the first coefficient, the last coefficient, multiply them together. So that's going to be a little bit of scratch work down here of 4 times negative 3, which is negative 12, and I'm looking for factors of negative 12 that add up to the middle term, or the middle coefficient of negative 1. So I want negative 4 plus 3, which when I add those, I get negative 1, but yet they still multiply to be negative 12. So we're going to rewrite this as, and I'm going to just do some scratch work here in the middle so I don't run out of room. This becomes 4y squared minus 4xy plus 3xy, that is still equal to the negative 1 there, minus 3x squared. Out of these first two terms, we can factor out what? We can factor out a 4 and a y. So we have 4y times 4y squared divided by 4y is y, and 4xy divided by 4y is going to be minus, the 4 divided by 4 is 1, the y's are going to cancel out, so we just get minus x. Out of these last two terms, they can both give up a 3. They can both give up an x, and 3xy divided by 3x is y, minus 3x squared divided by 3x is equal to x. Now we have that common factor showing up that we hope for when we factor by grouping, and that is the y minus x. So we're going to take that now out of those two terms and get y plus x times y minus x over 4y plus 3 times y minus x. And when we do that, the y minus x's cancel out and you get y plus x divided by 4y plus 3. Let me check my work. That, excuse me, is right, and that means we've got 2 more examples to do. And we have 2 more examples done. Here's my 5th example. 3 over x minus 1 plus 1 over x plus 1 all over negative 2 over x minus 1 minus 5 over x plus 1. This problem, none of these denominators share any common factors. So this fraction, for by example, needs to get multiplied in the numerator and denominator by x minus 1, this one by x plus 1. But the steps for this problem are the same as the previous example I just worked out. So I'm going to step out, pause the video, hopefully if you would like, give you a chance to work it out yourself, and then I'm just going to pop up show you the solution, and then move on to the very last example. Kind of give you sort of a little quiz here if you like. Voila, the solution. I hope this is your answer. Let's get to that last problem that is going to have fractions within fractions within fractions, and see what that's going to look like and finish this video. Hope that's what you got. 4x plus 2 divided by or over negative 7x plus 3. Here's your last example. We have 4x plus 2 over 1 minus 3 over x over negative 1 over x minus 3. Simpler sort of terms and expressions within every little piece of the problem, but a lot more fractions. And all this really means is we're going to have to find common denominators and put these terms together in a couple of steps as opposed to just one like some of the other previous problems. We're going to put these two together, we're going to flip that single fraction up, and then we're going to put these two fractions together because I already have one fraction in the numerator, and just keep working on the numerator in a couple of steps until finally it's equal to one fraction. Then we can flip this denominator up and multiply by the reciprocal. So to do that, we need a common denominator where with the only fractions we can work with at the moment, which is 1 minus 3x. So this 1 is going to become x over x, so we can have that common denominator of 1. And then, of course, x minus 3, x over x minus 3 over x. We now have this common denominator, so we're going to write this as x minus 3 over that single common denominator of x. And I'm just going to erase this and put it here because I want to make sure I have plenty of room to write the rest of the problem out. So we have, again, x minus 3 over x. Now that we have 2 over x minus 3 over x, we're going to, we have basically complex fraction inside of another complex fraction. So we're going to take this denominator and multiply by its reciprocal. That's going to give us 4x. I'm going to go ahead and write this over 1 because I'm going to be finding common denominators here in a second and leave some room to show that, plus, now if I take this denominator and I flip it up, it's going to be 2 over 1, that's the numerator, times x over x minus 3, which is going to be 2x over x minus 3. All over negative 1 over its own x minus 3. Now these two fractions need a common denominator. I only have one fraction on the denominator. I can flip it up, and I can, I could put some parentheses around these two terms up here and show distributive property, but it's easier to get these together first. So we're going to multiply this first fraction now by x minus 3 in the numerator and denominator to get our common denominator. And that means we're going to take this 4x and distribute it. So we have 4x times x, which is 4x squared. And 4x times negative 3 is negative 12x. Plus 2x. All over this common denominator of x minus 3. All over negative 1 over x minus 3 as well. Okay, now we have one fraction in the numerator. We have our main fraction bar here. And we have a fraction in the denominator. So we're going to multiply by the reciprocal of that denominator. So we're going to multiply by x minus 3 over negative 1. Well, we can see that now that we've gotten this worked out and we're multiplying by the reciprocal of the denominator, that we have this common factor of x minus 3, which is going to cancel out. We have 4x squared. Negative 12 plus 2 is negative 10, so minus 10x. All over, only left is negative 1 in the denominator. And there's really nothing to cancel out. If you'd like to write it, if your teacher would prefer you to write it like this, where we take the negative 1, like negative 1 over 1, or negative 1 over 1, or 1 over negative 1. They're all equivalent. These all represent negative 1. So I'm going to take this negative 1 and move the negative sign up into the numerator. and get negative parentheses 4x squared minus 10x. And that's the end of our last example, and I do appreciate you watching. I'm Mr. Tarrou. Bye! Go do your homework. Topic: complex fractions. That's when the numerator and or the denominator or both has one or more fractions with a in it or a power which is